Today, by popular demand, we're going to be talking rain barrels. I'm going to be building a rain barrel setup for somebody, starting at the most rudimentary and working our way up. And as I go, I'm going to explain how to build each piece of the setup, but also what it does, so you understand if it's something you're going to need for your setup, as well as possibly some alternate ways to set it up to maximize usefulness and efficiency in different situations. In its most rudimentary form, all a rain barrel setup is a container that allows rainwater to collect so you can take it out and use it later. So the one thing every rain barrel setup needs, obviously, is a barrel. We're going to be using these two 50-gallon barrels, each of which has a capacity of 190 liters, giving us a total capacity of 380 liters. But you can use any container so long as it's watertight on the bottom, it can't leak, and it has to have an open top to collect water. These barrels act as your cistern. They control your water capacity. So the important thing to keep in mind when choosing your barrels is that larger barrels mean a larger water capacity, but also a larger and probably more expensive setup. The only steps we're going to need to take to turn these barrels into the most rudimentary form of rain barrel is to cut open the tops and clean them out thoroughly. Now, to cut open the tops, obviously we're going to need a cutting implement, and I like to cut here on the inside edge of the lip. That allows us to keep this outer lip here, which will come in handy later on. So, we've now turned this into the most rudimentary form of a rain barrel. If you put this anywhere under open sky, it's going to collect rainwater that you can then use later on. But the first thing you're going to run up against is that it's a pain in the butt. You don't want to have to reach down in here and scoop out water with a watering can every time you want to use it. So, how do we fix that? The easiest and most versatile thing to do is to install a hose bib. We're going to need the bib. For this setup, we're actually going to be using two. We're going to need some waterproof adhesive, some sealant, and a drill with a large bit. This is the first time we're going to have a decision to make based on our individual needs and preferences. The key thing to remember here is that the tap isn't going to be able to draw on any water that's below its placement in the cistern. So where this tap is placed right here, it's going to be able to use all the water up here, but not that little bit of water at the bottom. So the logical placement would be here at the bottom of the barrel. The problem with that is it's going to pick up a lot more sediment placed down there, and it stops you from placing the barrel standing upright without building a special stand for it. So, I prefer to place my spigots right here, just a couple centimeters from the bottom of the cistern. The next choice we need to make is between a pump-fed and a gravity-fed system. Now, 9 times out of 10, I prefer a gravity-fed system. It's more affordable, less moving parts, one less point of failure. However, a pump-fed system has one advantage that is going to make it necessary for a few of you. A pump is the only way to allow our system to move water to a higher elevation. This means the cistern for our gravity-fed systems must always be at a higher elevation than anything we want to water. That's usually fine because as we get to later steps, you'll find we want to place our barrels next to the house, which is usually the highest point on the property. But there will be a few of you with unique situations that require your barrels to be at lower elevation, and for you, a pump will be required. For those of you that this applies to, don't feel left out, but you're going to skip over installing the tap with us, and instead, go buy yourself a pump that you're going to place into your cistern, and that's going to supply your hose or irrigation. For everybody else, let's talk about installing these taps. The first thing we need to do is mark out the position of our tap by placing it exactly where we want it on the barrel and tracing its outline with a pencil or marker. Then we want to drill out the hole as close as we can to the insides of the circle. Do not drill outside of that circle or the fit will be too loose and the tap will leak. Next, we're going to force the tap into our hole while twisting with the threading. This will cut rudimentary threading into the inside of the hole. Then back the threading back out a bit and apply our marine epoxy to the threads before screwing it all the way back into place. Lastly, apply more marine epoxy around the exterior where the tap and cistern meet, and silicone around the interior, creating a triple redundant seal. Then allow 24 hours for all that to fully cure. We now have our taps properly installed, but we're going to want to stress test them. To do this, fill your cistern completely full so the seal is under maximum pressure. We'll leave it full for an hour or two to ensure there's no dripping. Then open and close the tap a few times and make sure it holds up to normal stress. The harder you're going to work your tap, the harder you're going to want to stress test it. We now have a really useful, if somewhat simple, rain barrel system. It'll collect water when it rains. You have a tap you can turn on and off and attach a hose or an irrigation system to, and not a moment too soon because it looks like it's about to rain, which is where we're going to run into our next obstacle, which is that you're going to find that this system in its current state is not very efficient at collecting rainwater. Let's talk about basic rainfall collection efficiency. As it stands right now, we collect exactly the amount of rainfall in the surface area of our cistern. We have a 100% rainfall collection efficiency. Now, what that means is that if your local area gets 1 centimeter worth of rainfall, you will collect 1 centimeter worth of water in your cistern. So as it stands right now, you would need about a meter worth of rainfall, or an absolutely incredible amount of rain, to fill up your cistern. So how can we increase the efficiency? Well, if we can find a way to collect all the rainfall in twice the surface area of the cistern, we could get 200% efficiency. So for every centimeter of rain that falls, we could collect 2 centimeters worth of water in our barrel. But fortunately, most of us already have access to a system that allows us to collect all the rainfall that falls in the entire surface area of a house or building. That being the gutters. Now, as I said earlier, this isn't actually getting installed on my house. We use an artesian well, not rain barrels, but I'm going to mock you through this as though it were. The first thing you're going to want to do is go to where you have an existing downspout, and you're going to want to build up a platform to place your rain barrels on. Now, you can use cinder blocks or good strong pallets or pavers, whatever you have available. I would prefer to have it at least 18 inches or 45 centimeters off the ground, but the higher you can get it, the better your water pressure is going to be. That's why whenever you see a town that has a water tower, it's always really high up. Once you've built up your platform, you're going to want to place your rain barrel on top with the hose bib off the front so it's easy to access and you have clearance for attaching things like hoses and irrigation. Then you want to cut your downspout a good distance above the top of the rain barrel and add in an angle and some more spout so that the spout now drains into the rain barrel, giving you access to all of the water collected by your gutter system. There is one thing I feel I need to mention. I know that many people building rain barrels are doing it because they're concerned about trace chemicals in tap water. If you have a tin roof like I do or a tile roof, this is fine. If, however, you have a tar and shingle roof, many people claim it can leach trace chemicals into rain runoff. This isn't something I've ever tested, and I would hypothesize that any amount of chemicals that could leach into runoff in that short of a period of time would be so small as to be undetectable by any but the most advanced lab equipment. But I know that it is important to some people. So if that's you and you have a tar and shingle roof, or if you don't have a gutter system at all, there is an alternative method that we can use to improve our collection efficiency. For this setup, we're going to need some sort of sheet. It can be plastic sheeting like this, or tarps, anything so long as it's impermeable or close to impermeable to water. The bigger the better. We're also going to need 4 tall things. I realize that's like stupidly vague, but really our requirements here are not specific at all. All we need is 4 things that are tall, that can support the weight of our sheeting, and which can be placed in some sort of quadrilateral configuration. I made a scale model to demonstrate. This is about a 1/10 scale replica of our setup. Now yours can be as big or small as you want it to be based on the materials and space available to you. Obviously, the larger it is, the more efficient it's going to be, but literally the only requirement is that the bottom of your plastic sheeting must be above the top of your rain barrel. Our 4 tall things are acting as posts holding up our plastic sheeting. In essence, we've built a gazebo, but unlike a normal gazebo where the center part is raised up to allow rainwater to run off the sides, here we specifically want our center part to droop to allow rainwater to collect in the middle, where we've drilled a hole right above where our rain barrel will sit. Now this is a significant multiplier for our efficiency because this allows our small rain barrel to collect all the rain that falls in the entire surface area of this large sheeting. It's not as good as having a whole house and a downspout and gutter system, but it's way better than just the rain barrel without any sort of diverter. At this point, we have a pretty great rain barrel set up. It collects water efficiently, it's easy to use, you got an on-off valve that you can attach a hose or an irrigation system to. If you stop here, you have a pretty great rain barrel system that you'll enjoy for years to come. But we can do better. And the first thing that I'd like to address is sediment buildup in the rain barrel system, which can clog up our hoses and stuff. And this is one of the easiest problems to fix. We're going to be building a screen to separate debris and sediment from any incoming water. Now we can use any sort of screen here as long as it'll hold up to the elements. The smaller the mesh, the more debris and sediment you're going to keep out. I'm using this pool screen simply because I happen to have a ton of it laying around, but really any sort of screen will work. We're also going to secure it around this lip. Remember earlier I told you I wanted to keep this lip? This is why. We're going to secure it around this lip with zip ties. The reason I'm using zip ties is because I want something that's going to keep it in place as long as I want it to, but which I can remove later on if I want to as well. And for those of you who are unaware, you can stick a blade into this little tab in your zip ties and open them back up anytime you want. Now it's important here to leave a little bit of slack in the screen because that way it's going to stop any water from running off the sides and instead focus it down towards the middle. That's important. We don't want to lose any of that efficiency that we just put so much work into getting. Now, as a special bonus for the getting crud out of our water step, for my fellow denizens of tropical and subtropical climates, I'm sure you already did the math and realized that warm weather plus standing water equals mosquitoes. What can we do about that? These are mosquito dunks. Now they're supposed to be non-toxic. They're almost especially designed for use in rain barrels. They have a bacteria in them that's supposed to only be harmful to mosquito larvae. I'm not telling you whether to use them or don't use them, whether they're safe or not safe. I just figured I would float the idea and let you make your own decision because this is the best way to keep mosquitoes out of your rain barrels. At this point, guys, we have some pretty great rain barrels. Now, yours should look about like this, except they should be hooked up to a downspout or an independent water collection system. And there's really only one more thing that I think people probably want to know about, and that's how to daisy chain rain barrels. There are actually a bunch of different ways that we can go about this. First of all, we can go back to step 1, and instead of putting in spigots, we could lead to PVC elbows, bring them together, tee them out, and put a spigot on the end of that so that it's supplied from both barrels. Or we could stagger our barrels and we could put overflow valves on the top of each one leading into the next. But the way that I'm going to do it, because I don't even know if the customer is going to want their barrels daisy chained together or want them separate so that they have better coverage, is that I'm basically going to go back and repeat step 1 and do a second set of plumbing out the side of each barrel leading into one another. Those of you familiar with plumbing already know the parts that you'll need and how to set this up, but just in case you're not, let me go over exactly the parts that I'm using so you can copy me one to one. Now, to connect into each barrel, we're using a brass MPT to MPT, 3/4 inch. Everything here is 3/4 inch. We're connecting that to a PVC FPT to slip. And then we're going to connect that using pipe cement directly to a 3/4 inch pipe, which will then mirror the exact same parts on the other side going into the other barrel. And you could infinitely repeat this process from barrel to barrel, as many barrels as you have. For any of you who never studied fluid dynamics or had one of those questions on a test, let me explain how this works. By creating a flow between the two cisterns, gravity and water pressure is always going to push water from the cistern that's more full to the cistern that's less full until the two equal out. So, if you take water out of this cistern, water's going to flow from that one into this one until they level out. Conversely, if you add water into this cistern, water's going to flow from here into that one until they level out. And this works with as many barrels as you connect, as long as they're all on level. For example, if I took this one and placed it up an extra meter, what's going to happen is that this barrel is going to start overflowing with water flowing from this one to that one before this barrel can fill up. So in order for this setup to work, the barrels have to be on level ground. You also may notice that these two seals are leaking, and that's because I didn't cement them, because I don't know how these barrels are going to be used when they reach their final home. And I actually designed these so that these tubes can be taken off and we can put caps on so that if they want to use them separately, they can do that. Now, all this stuff took me about 10 hours spread over 5 days, but mostly that's because of the filming and everything. It should take you about 2 to 3 hours of labor spread over 2 days, because you're going to have that one overnight period for everything to cure. Don't forget, please, to leave a like and hype and all that stuff, because I do put a lot of work into these and it's important. But if you have any other questions or anything else you need to know, please feel free to ask in the comments section. I always try and address any questions that people have. And don't forget to come back here for more great home farming tips.